Dear students, welcome to the Social Science class of ninth Standard. Today, we are going to learn about ocean currents, a topic from the chapter Ocean and Man. To make you familiar with the concept of ocean currents, I would like to show you a video. I hope this video will help you to have a better understanding of ocean currents.
Pacific, but they didn't stick together. Quite the opposite. The ducks have since washed up all over the world, and researchers have used their paths to chart a better understanding of ocean currents. Ocean currents are driven by a range of sources: the wind, tides, changes in water density, and the rotation of the Earth. The topography of the ocean floor and the shoreline modifies those motions, causing currents to speed up, slow down, or change direction. Ocean currents fall into two main categories: surface currents and deep ocean currents. Surface currents control the motion of the top 10% of the ocean's water, while deep ocean currents mobilize the other 90%. Though they have different causes, surface and deep ocean currents influence each other in an intricate dance that keeps the entire ocean moving. Near the shore, surface currents are driven by both the wind and tides, which draw water back and forth as the water level falls and rises. Meanwhile, in the open ocean, wind is the major force behind surface currents. As wind blows over the ocean, it drags the top layers of water along with it. That moving water pulls on the layers underneath, and those pull on the ones beneath them. In fact, water as deep as 400 meters is still affected by the wind at the ocean's surface. If you zoom out to look at the patterns of surface currents all over the Earth, you'll see that they form big loops called gyres, which travel clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. That's because of the way the Earth's rotation affects the wind patterns that give rise to these currents. If the Earth didn't rotate, air and water would simply move back and forth between low pressure at the equator and high pressure at the poles. But as the Earth spins, air moving from the equator to the North Pole is deflected eastward, and air moving back down is deflected westward. The mirror image happens in the southern hemisphere, so that the major streams of wind form loop-like patterns around the ocean basins. This is called the Coriolis effect. The winds push the ocean beneath them into the same rotating gyres, and because water holds on to heat more effectively than air, these currents help redistribute warmth around the globe. Unlike surface currents, deep ocean currents are driven primarily by changes in the density of seawater. As water moves towards the North Pole, it gets colder. It also has a higher concentration of salt, because the ice crystals that form trap water while leaving salt behind. This cold, salty water is more dense, so it sinks, and warmer surface water takes its place, setting up a vertical current called thermohaline circulation. Thermohaline circulation of deep water and wind-driven surface currents combine to form a winding loop called the global conveyor belt. As water moves from the depths of the ocean to the surface, it carries nutrients that nourish the microorganisms which form the base of many ocean food chains. The global conveyor belt is the longest current in the world, snaking all around the globe, but it only moves a few centimeters per second. It could take a drop of water 1,000 years to make the full trip. However, rising sea temperatures are causing the conveyor belt to seemingly slow down. Models show this causing havoc with weather systems on both sides of the Atlantic, and no one knows what would happen if it continues to slow or if it stopped altogether. The only way we'll be able to forecast correctly and prepare accordingly will be to continue to study currents and the powerful forces that shape them.
I hope you have understood the video. The video discusses about many things related to ocean currents. We are going to learn about ocean currents in detail. First of all, What is ocean currents? Ocean currents are the continuous flow of seawater from one direction to another. They can be classified as warm currents and cold currents. Ocean currents are the continuous flow of seawater from one direction to another and can be classified as warm currents and cold currents. Warm currents. Warm currents are the currents that flow from the tropical or subtropical region towards the polar or subpolar regions. Cold currents. Cold currents are the currents that flow in from the polar or subpolar regions towards the tropical or subtropical regions. To make you have a better understanding of warm currents and cold currents, I'm going to show you a picture, a map of warm currents and cold currents. In this map, red arrow represents warm currents and blue arrow represents cold currents. And you can see warm currents. It flows from tropical region to polar region. Tropical or subtropical region to polar or subpolar region. The arrow, you can see the arrow starts from tropical region and it goes towards polar regions. Warm currents flow from tropical or subtropical regions towards polar or subpolar regions. Now look at the blue ticks which represents cold currents. They are the currents that flow in from polar or subpolar region towards the tropical or subtropical region. So cold current, it starts from polar or subpolar region and it moves towards tropical or subtropical region. I hope this picture helped you to have a better understanding of warm currents and cold currents. The temperature and salinity of seawater varies from ocean to ocean. This difference leads to density differences in seawater. The difference in density is one of the factors that cause ocean currents. We have learned that ocean currents are continuous flow of seawater from one direction to another. What causes the generation of ocean currents? The difference in density of ocean water is one of the factors that cause ocean currents. The difference in density is caused by the variation of temperature and salinity of seawater. Now we are going to look at the effects of ocean currents. What are the effects of ocean currents? Ocean currents influence the climate of coastal regions. Fog develops in the regions where warm and cold currents meet. The regions where the warm and cold currents meet provide favorable conditions for the growth of fish. These are the major effects of ocean currents. Ocean currents influence the climate of coastal regions. Fog develops in the regions where warm and cold currents meet. The regions where the warm and cold currents meet provide favorable conditions for the growth of fish. Grand banks. Next, we are going to learn about grand banks. The Grand Banks are among the major fishing grounds in the world. It is situated on the shores of Newfoundland to the east of North America. As it is the meeting place of the warm Gulf Stream current and the cold Labrador current, it provides suitable conditions for the growth of planktons, which in turn attracts fishes of many kinds. So we have learned that ocean currents, the warm and cold currents, if they meet in a region, it provides favorable conditions for the growth of fish. Example is Grand Banks, which is in Newfoundland in North America. At this place, warm Gulf Stream current and cold Labrador current meets and provide favorable conditions for the growth of plankton, and the growth of plankton attract fishes. Here is the map of Grand Banks. You can see the warm Gulf Stream current and cold Labrador current meets here. It is near Newfoundland in North America. Next, here is a picture of ocean currents. This is a map of ocean currents. Both cold and hot ocean currents are represented in it. Atlantic Ocean, Indian Ocean, and Pacific Ocean. In this picture, ocean currents of these three major oceans are given. Atlantic Ocean. It is surrounded by the landmasses of North America, Europe, Africa, and South America. There is South Equatorial Current, Brazil Current, South Atlantic Drift, North Equatorial Current, Gulf Stream, and North Atlantic Current. The boxes given in red color are warm currents and the boxes with blue colors are cold currents. The cold currents in Atlantic Ocean include Canary Current and Benguela Current. Ocean currents in Indian Ocean. Warm currents include Aguas Current, South Equatorial Current, and South Indian Current. Cold current include West Australian Current. Pacific Ocean. Warm currents include South Pacific Current, East Australian Current, South Equatorial Current. Peru Current is the cold current. Also, in North Pacific Current, Carrasco Current, North Equatorial Current are warm currents. California Current is a cold current. Next we are going to check our understanding through self-assessment questions. We have covered the topic ocean currents, especially warm currents and cold currents. With the help of these questions, you can analyze your understandings. Define ocean currents. What are the two types of the ocean currents? What are the effects of currents? Try to get answers of these questions. If you can't find the answers of the question, try replaying the video and find the answers again. Also, an enrichment activity is suggested for you. Prepare a list of warm and cold currents of major oceans in the world. In this video, we have discussed about warm and cold currents of major oceans of the world. You have to prepare a list of these warm and cold ocean currents. That's all about this topic. I hope you understand the topic ocean currents. Thanks for being in my class.